Hello everyone, welcome to Happy Tea Learning Tutorial. Today we are going to see how to use Databricks, which is data intelligence platform. We are going to perform a simple transformations using Databricks and see how to use the notebook feature within the Databricks. So this is a Databricks workspace wherein you can create a lot of things like catalog. In the catalog you can manage your tables, your data, your schema and your jobs and whatnot. Then we have jobs in pipeline, wherein you can manage your jobs in pipeline. You can create ETL jobs and schedule your pipe. You can create ETL pipeline and schedule your jobs and task over here. Then we have the compute, wherein you can manage your compute cluster. Like here, I am using a free edition where we have the serverless cluster. Now the next thing is database marketplace, wherein you can connect to n number of data sets available to the database marketplace for data sharing, and connecting with, integrating with different data sets or different application and components as well. Like we have Python, Tableau, Power BI, DBT, and all sort of things. You can also create models. You can also integrate the existing or the customized models. That's also available in database marketplace. Next is SQL editor, wherein you can perform all the editing options using the all the SQL functions, SQL queries. You can write and debug and query your data using the SQL editor, which is a fantastic tool, I would say, to use to start with. Then you have the queries, wherein you can analyze your queries which you have written in your notebooks or anywhere else. Then you can also have workspace usage demo, wherein you can check, okay, based on your usage of the platform or the workspace, where your resources are going. Okay, so like here it is going to generate my usage. So right now I have just started the terminal. Next is the Genie, which is your AI agent, AI assistant you can say, and the Genie which is going to help you out in everything you are doing or you are stuck on to debug and perform. Then you can also create and manage the alerts over here by creating an alert for your specific task or your scheduled job. Then there is query history, wherein I can query all the queries which I have executed during my session or while running. So this I can access it here. Even I can analyze more using this query results. I can use the versioning as well, right? If I want to revert back, I can use the time the query history as a time travel, right? So for time travel feature, going back in a specific point in time for my data sets or my results, or getting back that table which you have deleted by a mistake, something like that. Okay, some mishap occurred, and you can just go back and use the query results, which are always stored in the query cache as well. Then we have SQL warehouses, where you can manage your warehouse size as per the demand of your business or your volume of your data. Then you can scale it, minimum and the maximum cluster size. You can also run the size of the warehouse itself. You can set it there, Excel, large, or whatever. Then we have the job runs. So here it will show the job runs which are being executed in job pipelines or the ingestion pipelines we have. You can create ETL pipeline job as well as ingestion pipeline. Then we have data ingestion. So here I have ingested the data inside the volume. Okay, so there are three options. Either you can create a modifier table. Okay, then we have upload files or volume. So I have uploaded it to the volume, which is database internal volume, and then create table from Amazon S3. Since the cloud platform on which you have created your account, specific account, whether it is AWS, GCP, or Azure, since database provides flexibility to opt for any of the cloud platforms. So I have used S3 as my prime AWS account. So for my database, so it is helping me to also upload the volumes on S3. So I can leverage the S3 features and S3 capabilities for further restorage and archival, or the glacier or deep archival, or standard S3 policies, and I can do all that based on my usage and based on my requirement, based on my business, based on the policies. Okay, next is I can upload a volume over here, and you can give these are the existing ones, so I can upload it in the workspace. Like I have uploaded in the calorie schema. I've uploaded this volume, this CSV file, which is calorie sample volume. Okay, this is my catalog name, and then sample name, and the file name. I have also generated the output and password and CSV, so we'll see it further. Next is so this was for data ingestion, and you can other options are to ingestions through connectors or different APIs, right? So, or different applications. For example, you have Salesforce, you have SAP, you have Workday, ServiceNow, Google Analytics, SQL Server, and so on. Next is you can also connect it via connectors using OneDrive, Google Drive, Jira, GitHub, Webhooks, and there are n number of lists, right? You can see Adobe Analytics, wherever your file is, Apache Kafka, CloudTrail, Inventory, wherever your file is existing, you can connect it through n number of connectors for GCP as well, Cloud PostgreSQL, and uh, search, Google MySQL, Google Cloud MySQL, and so on. Oracle as well. Next is your playground. So here we can play with the data. Okay, what we want, function calling, prototyping agent, and all that stuff. So this is your basically for AI. You can call a function. It can provide you a summarization of your document or the PDF or the invoices which you have uploaded or any of the images. It could be structured, it could be unstructured data, or it could be a video as well. So unstructured data includes PDFs, images, and videos or the text, right? Or you can even translate your data, or you can just provide an input to an agent and ask them to summarize it, giving few pointers for your presentation or whatever needs you have. Next is like agents. So this is in beta edition. I've used it for sentiment analysis to create an AI agent. So we'll do this further using the RAG, and there are several other options. We'll explore this further. This is the new thing. Then next is experiments. Experiment is a place where happens. You can create your models. You can create a predictive model. You can create a forecast, or you can create a custom trained model, or you can create using GenAI and apps. Next is your features, wherein we can have and manage the governance of your objects. Like you have a Unity catalog to manage all the catalog features. You can govern them and implement the labels or the policies and have your data model governed and restructured and managed accordingly. Then next is your all your object control. Yeah, next is your models where you can provide you can use the existing custom models like Databricks. Dolly is there, which is again provided by Databricks. Like we have a lot of open source models which are available from Facebook like Meta, Llama, and we have Mosaic AI and a couple of others like Sonnet and ChatGPT and all of them. You can leverage as per your requirements like Grid, Search CV, and a lot of others. I have explored basic ones like Mistral 7D Instruct and Meta Llama. I've not explored. I've explored Mistral, Llama, and the variants of Llama and Mistral, and Gemma as well. So there are a couple of others which even I need to explore. Next is so here you can use using these models you can create your AI models or AI agents. And then serving is like how database is serving you on uh, basically compute. Okay, so there are a lot of options which they are providing it over here. So there is like these are the serving models basically Databricks GPT OSS. So these are all ready for providing you the flexibility and using your existing model. On top of it, the serving models are also available for your usage. And the other features like you can use it directly from here. Try in the playground, use for batch instance for your streaming purposes. So there are specific use cases for each of them which is already there. So these two are for batch instance as you could see. OpenAI ChatGPT is like GPT 5 is the latest version. Prior to that we had ChatGPT 4 as well. So it is currently being updated and managed, and we don't need to worry about this. I think this is automatically being taken care as soon as Google updates its own model like the GPT-4 to GPT-5. It launches notifications for all the existing associating parties, the third parties, as well as since it's an open source model, so it's there in the marketplace. So all the depending applications, like any of the cloud applications which is using the GPT, or which is fetching basically the information from the Google or from ChatGPT, are going to update their internal applications so that the information which we are fetching, or the model through which the model which we are fetching the information, should give us the accurate results and precise results, rather than the tokens, or the chunking and embedding whichever is happening, or creating the retrieval augmented models uh, using the RAG. So we should not get the outdated information in as an output. We should always get the accurate, up to date, precise information through the latest model. Okay, next is Quen Next Instruct. So we can see this is again available for batch inference. So you can use all that. Okay, now here what I wanted to specifically feature right now is the notebook which we have created. So I've created one notebook over here which is reading and writing data and practice Apache Spark. So let's quickly have a look at the Apache Spark notebook and the output which we have. So first let's go to our first notebook which is available here only. I think let's go back to the workspace and open our first notebook which is practice Apache Spark with Databricks. So it is going to include the basics. This is a magic command. Somehow it is not working with the serverless feature, but it used to work. So you just have to open this notebook, create your cluster, configure your cluster as per the minimum and the maximum cluster size. You can provide one for your POC, but then you can increase it eventually based on the volume of your data. Next, executing this command, so it will initiate the Spark. Then to create the Spark session, from PySpark.sql import Spark session. So this will create the Spark session. Spark. So I'm creating a Spark variable now. Spark session.builder.get or create application ID Spark.spark content application ID if has Spark or Spark content as else none. Print application ID. I wanted to print the application ID itself. So this is how it is working over here. Earlier it was giving me a little uh, fixing error, type error due to the Python version or something. Then I have enabled that type using the Python. So there is a setting. You just need to enable it if it is disabled in your account. By default, it is usually disabled for the type error or type mistake. So next is once we are done. Okay, let's see the output as well. So if we run this, so you will see the application ID. Okay. Next is from PySpark.sql import Spark session. Spark session, I'm creating a new variable now since Spark is already used. Spark1 Spark session.builder.app name first session get or create. Next is Spark2 Spark. If I'm comparing both the variables, Spark1 is equal to Spark2. Okay. So is it true or false? This is going to give me true or false. Okay. So this is giving us the result as Spark. Now this is a short form for SC, is a short form for Spark context. So we have just created a variable wherever we want to leverage Spark context. We can use SC as the alias. Now next is from let's see the basic group by function which I just learned in the demo session, which is like you can also perform from PySpark.sql functions, import abstract, import time. So df1 is my data frame, spark.range. We are providing a flexible range to choose it from any number and provide me their square roots. Okay, their squares. So we are trying to find the square of each number ranging from 1 to 1 million. Okay, so df1 is equals to df1 dot with column. I am adding another column, a new column using dot with column as syntax. Then column id multiplied by column id. Okay, now result, I'm going to store the result in the result variable df1 dot group by column id modulus 10, which is going to perform the modulus operation on the result set. So it will divide and perform the modulus on each result set divided by 100 and give me the results in some decimals. Then I'm going to aggregate that result and sum of square and I'm giving it the name of the column as squares, some squares. And what I'm doing is I'm trying to collect the result. So result.collect, once the results are collected, I will print the result count. So if we'll run this, we'll execute this cell with the result. Okay. So this is giving us the result here. If you want to see only this one, so it is giving us the counts as well. Here we have the result. And it also shows us the number of time and the number of tasks being completed for each and every query or the command you have written in one notebook. Okay, next, let's go to the next notebook, which is reading and writing data. Okay, here we already have the outputs and this is already connected. Okay, my first task is to read the data from a CSV file. So I already showed you, where the volume is. We can go to the workspace, and here is where I've created a inbuilt DBFS file. Okay, Databricks file, where inside the Databricks volume I've created a calorie schema. Inside the calorie schema I've created a sample volume, which is calorie sample volume, and here I have uploaded my file. This is my file. Okay, calorie sample CSV, calorie sample CSV. So I'm going to read this file. So how can I read this file once I've uploaded it? So customer dear, I'm giving, it should be calorie dear. I should give it as calorie dear. Okay, let's just change the name. Calorie dear, spark.read is the syntax, dot format CSV, dot option header. I want the header as true. What is header? Basically the first row. Then option info schema as true. Info schema is the columns and their data types. I want them as is. So I'm writing info schema as true and then load from where the path on which I have uploaded the file. It could be S3, it could be any storage place wherein you have stored or saved your file or uploaded your file. So once we did that, we can see once we run this. Okay, let me run this. We can see the Spark has read the file, and you can see the output over here. Using the display customer DF, I can give it as calories DF again. Calories DF. We have given it as calories, right? Let's run this. Okay. Alright. So we can see the results here. This is our output. And you can also expand the query to see, okay, how much it is being scanned and how much bytes being utilized, the request duration, the time spent, the peak memory, and number of rows retained. So there are 31 rows over here. This was for 1 month data. Okay, next. Let's go back. Here. Okay, next is display. So this is the file. Once I displayed the data frame, I get to see the file. I get to see it in a table format. So this was my table, which have customer ID, goal ID, achievement ID, distance ID, and this is the data. Calories count, effective date, and batches ID. Okay, so we can see 31 rows over here. Now next is what we are performing, print customer DF schema. So this is how it is giving me. This is the actual schema now which is there. So struct type, struct field, customer ID is integer type, which is true, struct field, goal ID, integer type, and all that. Okay. Next is we don't want to input the schema. We want to utilize what? We want to use the we want to create the schema and just use this schema if I have a customized schema or I have customized requirement. and I don't want to input the schema from the existing file. What I can do is I can create a schema like this. So first we'll do what? From PySpark.sql the type import star salary schema struct type. This is the syntax which we write. Then we have struct field, the name of the column, the first column which is customer ID, the data type which is integer type, and then true. Okay, we want this, right? Then struct field goal ID integer type true. Okay, so this is my fact table basically. This is my fact table, so that's why I've given it as true. You can, based on your requirement, you can set it as true or false. So I've given all the field names and all the attributes over here, attribute name and their data types. For effective rate, I've given date type, calories count, I've given string type. Other than that, all have integer type. Okay, so I've created the schema now, unlike above. Now here, what we are trying to do is, we are trying to achieve that I want to read the schema using this calorie schema instead of import schema as true. I'm setting this option, only changing this option. So calories df spark.read.format csv dot option header true. Yes, I want a header as my first row, which will read the column name or the column labels which are existing in the CSV file itself. Now schema, how is it going to read the schema? That is my data type of each column and attribute. It is going to read it from where? Schema type as calorie schema, where I have stored the schema. Okay, from here. Now dot load from where? From the path or the volume where we have stored the file. Okay, once you execute this, you get to see the results. So the difference between this pattern and this pattern, what are we achieving? So here the major difference is on the performance. When you are importing the schema, it is going to take additional tasks and additional job is going to be executed while we are using infer schema in the above scenario, which is truly unique thing. That is going to again cost you a credit, or that is again going to increase your number of tasks, and it is going to impact the performance of your overall result set, right? But here, if you are going to create your schema yourself, there will be no another job or task which is running over here. It is directly going to fetch the result and read the CSV file. Okay, so this is much quicker and in terms of performance, I would say, right? And there will be no job created in this one. Okay, so we saw that. Now next is, I want to print the schema, so you can just verify and recheck everything is as per your requirement or not. Next, another way out is to create a DDL for the same, like the way we created a schema over here using the struct field, using the PySpark method. Similarly, we can use the SQL to create the schema. So you can just write a SQL query like calories DDL schema, wherein you can simply write the schema in, you write it as in SQL, and then use this schema for creating your data frame. So here I'm creating another data frame, cal ddldf plug.read.format csv, option header true, dot schema calories DDL schema dot load. Again, this is again going to save us a lot as per the performance of the previous execution wherein we were using infer schema. So this is a better approach rather than inferring the schema directly. It makes the work easier if you use infer schema, but then at the same time it costs you on the performance because there would be another job which will be executed just in order to infer the schema as is. Okay, so most of the times the business case requires us to change and cast and modify our data types, right? So this is the much preferred approach there. Now I want to print the data frame, so I can use print cal ddldf. Again, it is going to uh, give us the attributes and their data types. Now I can also print the table print the data frame using the CSV which we have just read using DDL schema. So this is the data which we have again displayed using the display command. Okay, calories count. Now I'm going to use the SQL. So I want to convert and save it as my table. So in the table, I'm going to use, first of all, I'm going to convert this from Python to SQL. As soon as I convert from Python to SQL, this is not a Python, this is not a SQL command. So I can, once I change it to SQL or any other language like Scala and R, we can do that. Right now, this is a Python command. So I'm using cal ddldf, that is my data frame, dot write. I want to write. We have read the data, we have seen how to write. Now we are writing the data. So one way is to write dot mode dot override, save as table. I'm going to save it and giving it a table name as cal. And if you select perform just a SQL query, select start from cal, you get to see the results. Next is we have seen the results. Now this is not needed, then you can drop the table as well in order to save the space. Now calDF.write.format, I want to write the output in the packet format, so I'm using .write.format, that is packet. Mode is overwrite, and save it where? Save it in my output file path where I've given the volume. Okay, packet output volume path. So I've created it over here. If you see the workspace, you will get to see I've created another folder in the workspace. In the catalog, if you go my workspace, my catalog, calorie schema, inside my volume, I've given it as a packet. Calories packet folder where I have stored this packet file. Okay, these are the results which are being stored. So this is the volume part. I am just giving .save where packet output volume path where I have just given the path of where I have just given this path. Okay, then I want to display the result. Then display dbutils.fs.ls packet output volume path. So this is how we do it exactly. In caldf.write to, this is another way of writing which is much preferred than the other one, but I usually prefer the above one, basically saving as table and then utilizing it further. So this is another way out, which is caldf.write to workspace.default.cal table create or replace. Again, once you have given the catalog name, the schema name, and the table name, you can just say create or replace. Make sure to have the parenthesis. This is a syntax error. Most of the time we forget. We should not forget. Then next it's select start from cal table, and you can see your table is created. Okay, so this is what I have for today. Hope you have liked the Databricks platform, and you can also explore the same like I'm exploring, and I loved using this platform. Okay, so have a nice day. See you later. Bye bye.